but we're going to test using reject region. So hopefully, if you were not as comfortable on the reject region for the z-score, you'll get a little bit more comfortable with the t-score. The more we do, the more comfortable you get. And it happens with everybody. We did the p-value test first, so that's what everybody gets more comfortable with. But when we do this, you'll start to feel a little bit better about it. And I gave you the note page. Basically the same thing. We're identifying your degrees of freedom from n-1. We're using the table. And the nice part about it, there's no dividing in two. We're following a one-tail. We're following a two-tail. Notice everything is positive. So when we do a left tail, we just take whatever that number is and we make it negative. And as many times as I say the left is negative, the right is positive, I'm still getting some that are messing it up. So be careful when you make your sketch. So let's go right to the work of this. So you're going to find example 1 on page 377. You're going to find the critical values. Remember, we're going to test reject region. So when we have a left tail test, we're going to start like this. Everybody's going to make a chart. Maybe you could make 1 or 2 in your notebooks so that you get comfortable with it. Reject H0. Fail to reject H0. We're going to find this value right here. And before we called it a critical value Z, it's a critical value T, TC. Or sometimes they call it T sub O. Easy way to do this. Degrees of freedom, 1 less. You're going to go to table 5. You're going to follow the one-tail row across the top, and you're going to come down the column until the degrees of freedom is 20. So everybody go to A17, A18. Look at the table. Open your book down, A18. Look at the table. And pull out that value from it. Degrees of freedom 20. Follow your one tail all the way down. So what do we get? 1.725. And since it's to the left of 0, it'll be negative 1.725. That's it. If it's on the left-hand side, it's negative. If it's on the right-hand side, it's positive. So you guys try this next one. Left tail test. So I want you to go like this. This is reject H0. And make sure you label this. Fail to reject H0. Find me the TC. Use table 5. What do you get, John? What do you get? Well, open your book to table 5. Follow the one tail across the top, and what are you going to look on the left-hand side for? 13. Go do it. What'd you get? So since it's on the left, what do I have to do to it? Make it negative. Oh, sorry. Make it negative. It's on the left-hand side. This part's the real easy part. A right tail test. Same exact way. This is what's nice about your table. It doesn't matter where it goes. It gives you, on the top, one tail, two tails. So what you have to keep track of is your degrees of freedom. So follow your degrees of freedom. Follow your one tail, 0.01, and come down and give me that value. Open your box. Good. And since it's on the right-hand side, it's positive. You know how easy this is? There's your critical value. All we have left to do now is test with your Z-score and see where that fits. This is so much easier. So now we're going to do it. We're going to jump over to a two-tail. Two-tail. We have two possible tails. This is a reject H0. This is a reject H0. And this is failed to reject H0. TC negative, TC positive. Now, degrees of freedom is what? 25. Go to your table and this time follow the row across that says two tails. Two tails. Notice it's a one tail, it's a two tail. You do not have to divide anything. All you have to do is go to the row across the top that says two tail, and all of you should be on page A18. I don't want to hear later, I can't find this. A18. All the way across the top, two tails. Come down to degrees of freedom 25. What do you get? 1.708. What do I have to do now? There you go. That's it. There's your cutoffs. Make sense? Okay. Try it. You guys try it yourself. Number 3. Two-tail test. I want to see reject H0. Fail to reject H0. So what you cut off here? 2.131. Good, thank you. The left guy, negative. Remember, we're in the part now where we're using t-scores because, as you, you'll see in a little bit, that we don't know the standard deviation of the population. We'll only be able to find the standard deviation from the sample. So if you remember the confidence intervals, it makes your interval a little wider. It gives you a little bit more wiggle room. So it's going to have a different effect over here as well. Slight, and as it gets close to 30, you'll see it become more normal. Your test for your z-score was very similar. Sample minus the population over, we had the population standard deviation divided by n. This time we don't know the population standard deviation, so we put our sample standard deviation in there. Because we use our sample, we're going to use a t, not a z. Again, your sample must be done randomly, the population must be normally distributed, or the sample size greater than or equal to 30. So you're going to see in some of the examples it's going to say, it's approximately a normal curve, or you're going to see your sample size is greater than or equal to 30. They don't show you the test, but we'll just do a mental test to make sure. And again, major degrees of freedom. This works the same exact way as the other one does. Verify, instead of verifying that we know the population standard deviation, we say we don't know the population standard deviation. We verify that our sample is a good representation of your population. We state your claim, your alternative. We find your level of significance. We identify your degrees of freedom. We find your cutoff values from table 5. Same thing. We do your test statistic, t equals, and we see where it falls. We make a decision, and we interpret. Sound good? Okay? Not a lot different. In fact, the T is probably the easiest one. So the table kind of lends itself to your graph. One-tailed, two-tailed. You don't have to remember inverse norms. You don't have to do, should I divide it in half? Go right to the table. So a used car dealer says that the mean, we're looking at mean again, population, mean price of a 2-year-old sedan in good condition is at least $20,500. So how do I say that for my claim? Good. It's greater than or equal to, at least. That's the least it could be. HO or HA? HO. HA tells me it's complement. Okay. What tail test do we have? Follow the HA. I'll put it over here. And we're going to use reject region. We'll put it on the calculator when we're done, and that's where you're going to find your p-val. But we can't get your p-val off your table. It doesn't work like your table 4. So now, I need my critical value. Is my critical value going to be a negative or a positive? So let's put the negative here. So let's pull out our information. To use the stat that this claim is incorrect, and you find a random sample of 14 similar vehicles that has a sample mean of 19,850. Now they're in the same sentence, so this is a sample standard deviation of 1084. Is there enough evidence to reject the dealer's claim? Now, your claim is your HO. It still has to match up with the words reject with HO, support with HA. So that's always a good way for you to check to make sure you got the right claim. Okay, so now we're going to find your TC. How do I find your cutoff? How do I find your cutoff value? Table 5. Okay, go to table 5. What's your degrees of freedom? Degrees of freedom is 13. Find me your cutoff. Good. And we're going to make it a negative because we're on the left-hand side. Now all we have left to do is your test statistic. T is equal to x bar minus the mean, sample standard deviation divided by the square root of n. So we're going to say your sample information minus your population, sample standard deviation divided by the square root of n, not your degrees of freedom. So again, you're going to put it in your calculator. We're going to get negative 2.244. Remember their positions from table 5 gives you 3 decimal positions. So try to stick with the 3 decimal positions. Now, all we have to do is see where does that number compare to this number line. This is a number line. So does it fall to the left or to the right of negative 1.771? To the left. Oops. And where did it fall into here? Reject. So here's my negative 2.244. My decision is reject H0. I'm always testing the H0, the null. So if I'm rejecting the H0, do I agree with his claim? No. So I go to my chart, and when I find my claim is H0, when I reject H0, I use these words. There is enough evidence or sufficient evidence at a level of significance of 0.05 to reject the car dealer's claim that the cost of a two-year-old sedan is at least $20,500. Good. So not a lot different, right? Isn't this a little easier? Now, We can't get a p-value unless we go to your calculator. Now the calculator works real nice for this too. If you go to stat and you go to test, there was your z-test. Right underneath it is your t-test. So we go to your t-test. You can avoid doing the t-score for that. So we come down to your population mean. Everything works the same on this. Your sample mean, your sample standard deviation, your n, and you follow the tail of your HA. This all works the exact same. You come to calculate. Now look, it gives you your t-score and it gives you a p-val. P-val we can't get off your table. We can only get it from your calculator. So if I take my p-val, 0.0215, I could do a test for this. Now your calculator, when it does this, it keeps track as if it's a left or the right, because you tell it the tail. If it's a two-tail, it already multiplied it by 2. So we can avoid doing all this in here. We could test the p-val to a level of significance, fill it with zeros, and we can say less than or equal to, and we get the same result from this. But you can only get your p-val off your calculator. Does it make sense? We didn't change a whole lot. In fact, I think it made it a little easier because your table 5 is really nice to read. It tells you one tail, it tells you two tails. You no longer have to worry about, should I divide it in half? Do I multiply by 2? You don't have to do any of that stuff. Alright, so we start and we say that the insurance agent says that the mean cost of insuring a 2-year-old sedan is less than $1,200. Where did I go? It's less than $1,200. Mean cost, thank you, less than $1,200. This is the claim. Is it claim in HO or in HA? HA. So somewhere down here, I should see the word, is there enough evidence to support the agent's claim, right? His claim is HA. So the opposite, the complement, is HO. What tail test do we have?
Left tail.
Left tail. Boy, you're on a roll, Will.
Thank you.
So this says reject HO. Fail to reject HO. Okay, we need a cutoff. Anybody find me a cutoff?
Negative 1.44 L.
No, very good. Anybody not get that?
Why do you reject HO to the left?
Because that's where our tail is, to the left. So anything smaller than that error, we're going to reject. So negative 1.440. Did everybody find that?
Yes.
Anybody not get that? Okay, so our next step is to test this guy. We have a t-test. We'll pull out our sample. Our sample mean is 1125 with a sample standard deviation of 55. And we're testing at the 0.10, and they did tell us we're normally distributed because n only has 7 in it. So they have to tell us we're normally distributed. So we test your sample mean minus your population mean over your standard deviation divided by the square root of n. And what's your t? Your test statistic.
Negative 3.600.
So 0.6.
7.
07. Thank you. 0.607. Now, this is called a test statistic. Why is this called a test statistic? That's what we get from your calculator. That's what we get from testing the sample, right? We're testing using your sample. So our test for this is called a test statistic. This is called a critical value. This is why I use the C instead of their sub O. Don't get these two things confused. This is your critical value. This is what goes on your chart at your cutoff of your reject region. Then we check there and we say, oh, that falls way over here somewhere. So where does it fall in? This is my decision. Reject H0. That's my decision. My decision doesn't go in my interpretation. My decision comes from first testing this. And I take it off my reject region. Then I say, okay, my claim is my HA. We know because we're going to use the support words. If we reject the H sub 0, do we like the claim?
Yeah.
Are we supporting the claim? Yeah. So when we reject this, there's enough evidence, there's sufficient evidence to support the claim that the mean cost of insuring this 2-year-old sedan is less than $1,200. We can put it all together like that. Okay, so that's from start to finish. Okay, not so bad. All right, we'll do one is, and I think they have a right tail test with the calculator. Again, if you like your calculator, for this guy, you can absolutely use your calculator. I love the calculator test for these. Stat test, it's right underneath your Z. So you put your mean in for your population. You put your sample mean in. You put your sample standard deviation, how many in your sample, and you follow your HA. It gives you your Z-score. It gives you your p-val. This is the only place you're going to find the p-val. Because what happens with your T-curves, they constantly change. They're not normal. They go based on your degrees of freedom. So they kind of start up here, and then they start to go down a little bit more, and then they come down a little bit more, and eventually they come down. When n is 30, they get really close to where your Z-score was. So there's really not a way to define the area under the curve at any special point. But your calculator, of course, does. It's pretty close. So let's try one that has an equal sign here. And this is nice because you don't have to divide anything by 2. You don't have to double anything. Nothing. So an industrial company claims that the mean pH level is 6.8. You randomly select 39 water samples, and the sample mean, wait, crap. Let me give you that. And the standard deviation is 0.35. Okay. Get this set up with the tails, guys. Get a graph set up for me. All right, so this is my claim. What tail test do I have? 2-tail test. This is my HA. So 2-tail test. Find me the cutoff values for this. They are the same value. One's a positive, one's a negative. You only find one value. Label these guys. Make sure you label these. Okay. Find me your cutoff values. Did you look under the 2-tail? There's a 1-tail, then there's a 2-tail. And degrees of freedom is 38. have symmetry in our curve. All right, now we're going to test. We're going to find your test statistic. Take your sample mean minus your population mean, divided by your sample standard deviation, divided by the square root of n. And t is negative 1.784. Now, where does that fall? In the reject H0 or the fail to reject H0?
Fail.
Fail. Falls to the right of this guy. So my decision is fail to reject H0. If we fail to reject H0, do we agree with the claim? If we fail to reject it, we go along with it, right? But we have to follow your chart, and we say there's not enough evidence at this level of significance to reject the claim that the pH level in the water nearby is 6.8. I'm going to spend all day today, and the minute you go to do this, you're going to all be confused, so stay with me here. It's not that hard. Okay, so let's cut over to example 6. Example 6, and we're going to use your calculator for a p-valve test. A Department of Motor Vehicle office claims that the mean wait time is less than 14 minutes. Whatever they claim, you write that down, and then you decide, is this the HO or the HA?
HA.
So what's the HO? Good. What tail test do I have? A left again. So this is reject H0. This is fail to reject H0. Find me your TC. Is it going to be, am I going to have to make it a negative or a positive? A negative. So find me your TC. You technically don't have to do this if we're testing a p-value, but let's just throw it in there. I will say that again. 383. Thank you. Okay, so we're going to test your test. We're going to do your test statistic. Let's put our sample. We have a random sample of 10. We have a mean time of 13 with a sample standard deviation of 3.5. So we've got 13 minus 14 over 3.5 divided by the square root of n, well, which is 10. Okay, and your t would come out to be negative 9.035, right? 0.9035. If we were testing with your reject region, where would it fall? In what part? So now, remember, a T is associated with the p-valve, and this level of significance is associated with this TC. So this TC says negative 1.383, and this level of significance is its area under the curve is 0.1000. Now, we found this T, but here's our problem. This is my test statistic. I have no way to find out the p-value for this. So instead, I go to the calculator. Oops. I go to the calculator. The calculator will give me the p-value. So I go to stat, test, I come down to 2, and I put my information in. My mean is 14, my sample mean is 13, my standard deviation was 0.35. Thank you. 3.5. My N was 10. My tail, still the same. Now, here's my T, there's my p-valve. You can find it in your calculator. Guys, give me 2 minutes and we'll wrap this up. So 1950. So this is where this comes into play. This is my test statistic. So the same way we did before. These are related, these are related. You test your two T's to find out what area falls in your reject region. You test your two p-values to find out what your p-val test is. So we're going to test our p-val, which is this guy, against your level of significance, which is this guy. So your decision says this is greater than, and your decision is still failed to reject H0. So it still works the exact same, but you can't find it on your table. You have to find it using. No, as I asked for a p-val,